All right, hello everyone. Today we're going to talk about the ocean's effect on weather and climate. So when it comes to our oceans, it's important to remember that our oceans cover 72% roughly of the surface of our planet. And so they do have a big impact on the climate and weather of our planet. With our oceans are always moving and circulating. Water is going from one place to another. And as they move, heat gets transferred. There's an exchange of heat between the oceans and the atmosphere, as well as the land, but we're focusing on the oceans, that help to generate patterns of circulation that influence our climate. So what is climate? Climate is the average pattern of atmospheric conditions for a region over a span of many years. And by many years, I'm talking you need decades worth of data. Scientists who study climate look at things like rainfall, temperature, and humidity, which on a daily basis we refer to those as weather. So like today happens to be a very cloudy, rainy day. That's our weather. The climate of an area depends on its geographic location. There's the latitude, so how close or far you are from the equator determines how much solar energy you receive. And that solar energy or energy from the sun helps to drive all of these processes. And then the other major factor is how close you are to a large body of water, whether that's an ocean or a very large lake. The reason that body of water is important because that now drives or provides a source for water, which is going to lead to precipitation. When it comes to water, water has a very high heat capacity. That means that it's going to absorb a lot of heat before it changes temperature or changes state. Because of that, areas near a large body of water are going to have more moderate temperatures. The air does not change there as quickly as, say, the air above the land, because land does change temperature more quickly. Air is going to move around as it changes its temperature, and a change in temperature leads to a change in density. And our Earth is heated up differently based on the different compositions of where it is, whether there's more land there or more water there. All of those differences lead to wind. Wind is caused by that uneven heating. So if we watch here in our little video, during the day, the land is warmer. At night, though, the land cools off, but the ocean, or again, lake water, is going to stay the same over the course of just a day, causing changes and differences in the air temperature above those two. So that's why coastal areas tend to be windier than more inland areas. Even places like Chicago, known as the Windy City, it's on the coast of one of our Great Lakes. That leads to some of the wind. Next, with all of these changes and movement, it ties into the water cycle that we talked about last week. When water moves from place to place, when it goes from liquid water and evaporates, that takes energy. When it condenses and falls as rain, going from a gas to a liquid, that releases energy. And all of these help to influence our climate. And again, our oceans, they're covering 72% of the surface, absorbing that solar energy and causing the water to evaporate, making them the largest source of water in the atmosphere, in our water cycle and on our planet. As water evaporates, it becomes water vapor, and that water vapor goes up into the air. How much water the air can hold depends on the temperature of the air. The warmer it is, the more water vapor it can hold, and that creates a positive feedback loop. More water vapor, higher temperatures, we get more evaporation. There we go, more water vapor, higher temperatures, more evaporation, more water vapor then, leading to higher heat. And this cycle will continue and continue as we get more and more water until it reaches the maximum. And typically this would be reported on your news or your weather event as 100% humidity. And when it gets high enough, then you get storms and rain. Areas like the equator where the sun's rays are most intense. We have a perfect recipe of solar heating, lots of water vapor. We can see that there's lots of ocean right here to lead to very violent storms such as hurricanes, which will be the focus of our notes next week. Those hurricanes tend to form around the equator because of things called Hadley cells that cause all that warm water to collect and rise. And then that storm or hurricane is going to get pushed across the ocean. In the case of us on the Atlantic in Texas and on the Atlantic coast, we would be over here, not quite pictured. Hurricanes form here off the coast of Africa. We've got that nice warm water at the equator of the Atlantic Ocean, and then they get pushed across. Winds are moved and are turned in part due to the deflection of the Coriolis effect. This is a topic we'll focus on later. And lastly, I almost forgot. If you want some more information, I've got some links here to a couple of different YouTube videos that you're welcome to watch at a later time.